Namaskar, my name is Manish Kumar and I welcome all of you to my channel. So in today's video, we are going to learn about branching and trigger rules in Airflow. So without further delay, we will go to the laptop screen and discuss everything in detail. Alright, so I am at laptop screen now and you can see I have given the topic name of today's video, that is branching and trigger rules. So what all potential interview questions can be there? So we are going to discuss it first and then we are going to answer all of these questions in detail and a lot of more things, right? So the first question is, how do you run conditional tasks? So this is one of the famous questions that you can be asked about. How do you run conditional tasks? When you have a if else kind of condition, then how do you run those tasks, right? How to run tasks in parallel? Although this question is not that famous, but we are going to learn in this today's video. What are trigger rules we have? So again, this question can be tricky when they are asking in the interview. So trigger rules are there, and how many trigger rules are there? So we are going to learn all of those, and also we are going to see how these trigger rules affect the skip propagation, which we are going to see again in today's video. So before going in today's video, what I'm going to do is I'm going to lay out the foundation of what we are going to achieve in some upcoming lectures, right? So already we were talking about that we have three endpoint like product page, checkout page and cart page, and we are going to collect all those data into data lake, right? Let me pull up the architecture diagram that we had shown in the earlier lecture. Okay, so this is the diagram that we had started with the pipeline that we are going to build, right? So already we have the API of product page, cart page, checkout page. Every page we have, I think we have a user login, product and checkout, not the cart page. Okay, and we are collecting all the API details into data lake, right? This is what we had to achieve. Now to achieve this, we have to do a lot of things, right? This is the simplest example that I had taken at that time, but this is what we are going to achieve. Not in today's video, we are going to do the layout in today's video, and in the next lecture we are going to actually implement these things and actually putting everything into a data lake. Of course, for us data lake is going to be one of the folder, not S3 or something. Maybe in future we will put the same data onto S3 as well. So now this is the highest level picture that we drew, right? Now we are going to do everything in action through Airflow pipeline, right? So now we are going to build the pipeline. So to build the pipeline, we need all these three API, right? I have three API of product, checkout and user. So these are the three tasks that we are going to create in our DAG. So basically we are trying to write a DAG which will consist of multiple tasks. So this is the first task we are going to create, second task, and this is the third task. These are the three tasks. All of these tasks will write the data into individual folders. So this will write in its own folder, this will write in its own folder. So everyone will write the data in different three folders, right? So we will have a three folder and all the data from different API will be pulled here, and all of those will be pulled in an incremental manner, which we already know, right? Now these three folders, we collected all the data, but now we want to merge this data, correct? Because in real time, I don't think anyone is going to give you something like get all endpoint, right? So already you have three endpoints. So use those three endpoints, bring all the data into three folders, and now bring all those three folders data into one merged folder, which will be considered as a final data, which we are going to store in a data lake. For us, data lake is again a folder because we are trying to mimic the same thing, right? After merging the data, we want to notify the team that okay, we have written the data into data lake. Now you can start processing your pipelines. This is how we are trying to build, right? Now we will take a little further about the branching. So here I want to teach about branching. So branching means here I am collecting data in three folders, right? But before merging the data, right, I would say before merging the data, I like to I like to know if my data is correct from the API or not, and that is where what I want to do, rather than writing directly into merge, I want to check first, right? I want to check the data, that do we have a correct data in checkout amount, maybe amount, right? So amount cannot be zero. So those kind of things I want to check. So let's say I am selling lakhs of product, right? And even my amount is not less, not greater than 100. Then in that case, of course, my data has some issue, right? So in that case, maybe I want to go through the checkout page first, understand if the amount is greater than 100 or not. I'm just taking an example, but there can be another possible scenarios, like you want to run pipeline on weekend on a different set of use cases, and weekday different set of use cases, or you want to skip the pipeline running on holidays, right? So there can be multiple possible scenarios. Basically, I am trying to do if else of a task here, right? That if the task has to be run on that particular day or not, based on some condition. That is where I am doing checkout amount here, but there can be other possible scenarios as well, and we do have multiple possible scenarios where we write this kind of DAG. Okay, so this is one of the checkout DAG. Now we already know that checkout DAG, like, it should not go into the flow. If this is going into the flow, I want to notify, but this is a alarming situation. This is not a normal situation that, okay, your pipeline got succeeded or failed or something like that. This is alarming situation that we are getting literally zero or some random number which is not making sense in the data to write. So we are going to this flow, we are not going to this flow, right? So that is where this task, right, this fourth task, these are the three tasks and this is the fourth task. So fourth task will decide, before putting the data into the merged folder, that is data correct or not, and that is where this flow will run, right? So now I'm going to make it a little bit more clear, but that is where this branch Python operator concept will come. That is basically a branching, right? So branch Python operator is used for branching, and branching means basically if else condition on a task. So if you are doing if else condition on a task and you are running only one condition which satisfy that rule, then you are basically doing a branching. That's it, right? And that is where we use branch Python operator. So we are going to see all these things in detail, but for now I'm going to make this layout a little bit more clearer, and then we will go and talk about branch Python operator, and then we will see some issues, then we will go to trigger rules. Okay, so here this is the more clearer picture that I just do here. The same thing, product page, checkout page and user page, which will bring all the data, and then there will be another task which will be a read raw. It will run and it will check if the condition satisfy for checkout or if the condition satisfy for merge, right? And then either this flow will go or this flow will go. Both flow cannot go in one diagram. Okay, now in real time you'll see multiple times a situation where this kind of situations are there. Then you'll see one dummy task which is of a start. So basically it says, okay, job is starting, and at the end you will see there is a end task. So these are the tasks that we create by choice. Okay, and now start task will run 3 parallel tasks, and then this will basically merge into end. So there are two things here we are doing, or maybe jargons that you will see, you will hear about fan in and fan out. So fan in and fan out are just a fancy term. This is nothing but a fancy term. Okay, so what we are doing here, fan out means one task is splitting into multiple tasks. So if you see here, start was just one task, but it is splitting into multiple tasks, or to be precise here 3 tasks, right? So this condition will called as a fan out, and inverse of that is fan in. So basically you see here 3 tasks are getting merged into one, and that is basically called fan in. So you now understand these two fancy terms, fan in and fan out, nothing but a simple fancy names. Okay. Now okay, fan in and fan out is done, but what about this start and end? Why do we need, and what this start and end will do, right? So start and end are just a dummy operator. Initially, like earlier we used to say dummy operator, but now the name has been changed and we now call it empty operator. So these operator basically are of course used for creating a task, but that task does nothing. Literally it do nothing, just it is there to make our pipeline looks a little more clean. That's it. Okay. And but one thing, but scheduler knows about this task. Okay. So a scheduler understand this task and this gets triggered, but this will get completed within a second, right? Within a millisecond also, because it has nothing to do. It is just there to make our pipeline little bit more cleaner, right? That's it. And most of the time you'll see start and end at the first and the last, and this dummy operator is there. So dummy operator will take just your task id, right? Task id as a name and DAG the one we provide, right? So these are the two operators we just need to pass. That's it. Now we'll talk about this portion, right? Because this is the most interesting portion that we have to talk about today, is the read raw task, right? So we are going to talk about read raw task, and this task uses branch Python operator. So this is the operator that we use to do the branching, or in a simple term, if else condition of a task, right? So how can we write the branch Python operator? Because if I can write the branch Python operator here on the notebook, I can easily replicate the same when I am writing the actual DAG, right? So let's first understand about branch Python operator. So I'll give the task name as task, and here now I'm using the branch Python operator, and branch Python operator is again nothing but a Python operator, a special Python operator, I would say. This is a Python operator and this is a branch, right? So this is a special Python operator which do branching. It does not actually, it does not take anything apart from, now it does not take anything extra argument which we were using in Python operator. So basically all the arguments will be as it is like a Python operator. Only one condition is there, that branch Python operator should return the task name. Okay. So only thing, it has to return the task name. Otherwise every argument will be same as the Python operator. So in Python operator, if you remember by now, we'd give task id, right? We give DAG, and what else? We give Python callable, right? So maybe I'll just pass here Python callable, and the value is, let's say, decide flow, right? I want to decide the flow, which flow will run, right? And maybe if you want template dictionary, and then OP keyword arguments, OP arguments, if you want to pass, all those things are available here also. Okay. So now in Python operator, I gave the function name decide flow. So I'll just write a function called decide flow, right? And this decide flow function will check if the amount, so for now I'm setting the amount and then I'm checking it. Okay. Check out amount equal to maybe 90, right? And I'm writing if checkout amount less than 100, right? This means alarming situation is there. So now return which task? Return the checkout task. Okay. So here I am giving the task name. If you have okay, if you have more than one task, then you can pass it in the list as well. Okay. And else return merged, right? So these are the two tasks we created here. If you remember here, I created either a checkout task or a merge task. So either this flow or this flow. So this is what decide flow function is doing. And of course here I have given the hard coded value, but this value has to be calculated, and that calculation will be done in the next to next class. Okay. So now we are good. Everything is working. Everything should work as expected, what we know till now, right? So now we will go to the this one DAG folder, and we will start writing our DAG. So I'll go here, and now I'll start writing DAG. So already you know how to write a DAG. We are inside a DAG folder, and we will create a new file. And in the last Hindi lecture video, I gave the name as pipeline layout. So here I'm just giving a pipeline because I just have to make the same content in English. So I'm just doing it this way. Okay. Pipeline layout.py. I'm just giving a underscore name here to distinguish from what I was teaching in Hindi lecture. That's it. The same I did for incremental API as well, which I talked in the last video. Now I have to write a DAG, right? Writing DAG is pretty simple. Everything we know what we have to write. So first I am just copying the layout, right? And then not layout, I'm just copying the import statement and creating the DAG. And after that we will start writing our flow. And what we are going to write today is this one. But remember one thing, I'm just going to do the layout. Okay. I'm not going to implement actual things. Implementation will be taken place in the next lecture. Okay. That is, I think, lecture number 11. So everything has to be done from here. Okay. Now I'll do import statement here. So I did the import statements. You already know about Python operator, bash operator. Now I did one empty operator from operators.empty, and from Python itself I brought another import which is branch Python operator, right? So these are the code that is there. Now I have to create each and every task that we just now decided. What we have decided? We have decided that we are going to create a start, right? So I'll just write start here. Start is the task, and the task of course will be the empty task, right? So empty task will use empty operator. It will do nothing, but it will be there to make our pipeline look cleaner. So I gave the task ID and I gave the DAG. I'm using auto suggestion. Now since I'm using start, I can use end also to create the task here. So two tasks are already created, right? Now the third task is basically product page, checkout page, and user page. So I'll just create one and then replicate it, right? So I would say product page, right, equal to bash operator, right? And inside bash operator I'm just giving the bash command. I'm not using Python operator because again that will take a lot of time and then logic to be performed. So I just created this product page and task ID, bash command, and DAG. Now you see these two suggestions are coming because I already created this kind of code in the last video. So that's why I'm getting this kind of suggestion. So I'll just accept it, and I already have all three tasks which is there. One thing you will be thinking about, how we are going to stitch all these things together, right? Because I have a start and then I have multiple tasks, and then again multiple tasks has to be fan into one. So how are we going to stitch it together to look like a pipeline, right? And your pipeline will look like exactly same what we are seeing here on the Airflow UI. So those things we are going to see, and also I'll talk about how this dependency has to be set once all task is created. So for now I have created all these three tasks. Now the fourth task has to be created, that is read raw, right? And that is where I am going to use branch Python operator, because you remember now, right, that either this flow will run or this flow will run. So how that flow has to be taken into consideration is through the branch Python operator. So I will do read underscore raw, and see suggestion I'm getting branch Python operator, and inside branch Python operator task ID, right, Python callable and DAG. That's it. Now Python callable says decide flow. Now decide flow method has to be written, right? So what I'm going to do, I'm going to create a method or a function called decide flow, and in this already I'm getting again suggestion checkout amount. I have set it as 50, and if checkout amount is less than 100, then I have to go through the checkout task. This is the task name. Again I am saying this is the task name. This is not a normal string syntax that we are returning. Of course this is a normal string, but this is a task name. So, and from there itself, see, now I have to create two tasks, checkout and merge, right? So I'll create now checkout and merge, and also I'll tell you the flow of this one. So first, before going there, I'll just create checkout. Okay, now I created checkout. Now I'll create merge as well. So merged, sorry, suggestion is not there. Yeah, I got this suggestion. So now all the tasks from here, checkout and merge is created. Now for checkout, alarming is there, but merge notify is there because just now we want to notify it. So now first I'll create alarming situation, right? And then what else? The last one is notify, right? So I'll create notify team maybe, right? Okay, so everything is in place now. I have created all the tasks. Now understand what will be the flow of this task, right? So how this flow will occur. So the first task that will run is this one. Okay, the second task which will run is this one. This all will run in parallel at second place. Okay, then this will go at third. Then either this will go this way 3.1 or 3.2, but this will not go in both the places. Okay, so let's say if I go from here to 3.1 wala flow, then in that case 3.1 and then this will be 4.1, right? And the same way if I'm going this flow, then 3.2, then 4.2, and this is the fifth. So this is how the flow will occur. First, second parallel, third either 3.1 and 4.1 or 3.2, 4.2, and then fifth. So this is the total flow that is going to run, and this is how we have done. Now I have to set all the dependency. So we are going to do in each split. Okay, although I can do everything in one go, but I want to show you in bits and pieces. So here if you see, I just want to achieve this. This is the only thing that I am currently interested in. So if I have to achieve this, so start is the first task, and to set the dependency, you already know what is the operator name, right? Start and then double right shift operator. And here I can see there are 3 parallel tasks has to be run. So all the task name we have to pass into a list, and those list will run in a parallel. So that is what we were getting suggestion here also, that product page, user login page, and checkout page. These are the 3 pages that we want to trigger after start, and because this is in a list, so this will run in a parallel manner. Now after running this, right, this flow is done. Now what I want to do, I want to do next. So next is basically from this 3 flow, right? From this 3 flow, I want to run this portion, right? So for this portion, what I'm going to do, I'm just going to copy this entire thing and I'll paste here, and then the next thing is read raw, right? If you see here, read raw is there. Now once I have read the raw data, right? Now what I can do here from read raw until here, right? If you see the green section. So this is how I am going to do again. So read raw will do checkout or merged, right? It will go to checkout and merge. Now checkout itself, right? Checkout itself has this condition, checkout to alarm, right? If checkout is running, then checkout should run on alarm. So what I'll do, I'll say checkout and alarming situation, right? This one only. Then if flow goes this through, then merge and notify. So I'll write here merge and then notify team. And at last, if you see here, this is the flow, right? That this has to be done. So what I'll say, alarming situation and notify will merge into end, right? So again, these two can run in parallel, right? Although this is not running in parallel, but this way, right? Alarming situation or notify, and then this will go to end. This is how we have created entire DAG, right? And we have basically set the dependency, we have everything running, branching, everything is in place. Now I don't think there should be any issue, but let's see if everything is working in place or not. So I have saved this content. Now I am going to localhost 8080. By now you should be very familiar with localhost 8080, and this is where my localhost 8080 is running. I'll just go to DAG or home or refresh anything, and I'll just go to DAG, and I can see there is 2 DAG which is having import error. Ideally it should have 1 because I was doing some testing, but here a pipeline layout, it's saying error, right? This is the one that we created just now. If you see here, unexpected keywords, every time I'm making this mistake, schedule interval 1. So because that is coming through auto suggestion, so what I'll do, I'll just remove this schedule, right? It should be schedule, not a schedule interval in Airflow 3.0. Now if I go here again, it should be gone. I'll just refresh the page. Yeah, that is gone. Now I'll see where is my pipeline. What was the name that it gave? Okay, it gave the name pipeline layout example. I should have changed the name here as well. Let's see if I get a different pipeline. Yeah, this is the pipeline that I got. Okay, a pipeline layout example. Now here you see multiple tasks are there, the one that we create just now. And if I go here in the graph view, right, see whatever we drew, right, we were drawing everything, and now everything looks like what we were expecting. We were expecting like this: start should have 3, then 3 should merge into 1, 1 should again split into 2, 2 should run parallel, and then it should go to end. The same thing happening. Start is going with 3, 3 is merging into 1, 1 is again splitting into 2, these are running parallel, and then it is merging into 1. So this part we are done. That means we have set the dependency correctly, right? Now it's time to run the task and see everything in action. So I'll just unpause the DAG, and then first run should be up, right? Starting every 2 minutes, but why there are multiple? Okay, I don't know why multiple tasks ran in the first place. Okay, what was the time here? It was 350 and this is 352. I think the time when I just clicked on pause, right, at time 352 became, and then it ran the like just 351 50 second and then 352. So this was a very small gap of maybe 2 second 3 second. That's why it created 2 task, and this will run on every 2 minutes, right? Where is my schedule details? See, schedule every 2 minutes, right? So I'll just go here and see what all things are happening here. So I can see start is success, right? If I go here also, I can see start is success, then checkout page, product page, everything is success. Merge is skipped, notify team is skipped, and end is skipped, right? Now understand the situation here. We ran the pipeline. I'll go to this part again, right? See, I went here, start succeeded, good. This page are working, at least in our layout example, working good. Redraw good. Now it decided, right? It decided that what is the checkout amount. Checkout amount was 50, but the value threshold was less, if less than 100. Yeah, that condition satisfies. Basically, checkout page it will go, and in checkout page, wait, I should not have clicked it because that is showing the logs. So checkout page, and it ran into the checkout flow, right? And it got succeeded, everything was working as expected. But there is one condition, that it got skipped, that I am fine with. But here, why end is skipped? End should not be skipped, right? Because if we are going through this flow, end should be running in every situation, because that is how I'll come to know that, okay, my everything has been completed. Let's say if there would have been a multiple task after this also, it would have been skipped. And that is where this question was there, where, during starting when I was explaining about the potential interview question, how this skip propagation works, right? See how this skip propagation works. And that is where the next concept coming is trigger rules. Okay, so now we are going to talk about trigger rules. So if you see here, this is the trigger rules. I have task 1, task 2 and task 3, right? And this is a sequential, this is running in a sequential manner. Like if this got completed, good. This got failed, okay. Now the next task will not run. This will not be running. This will not fail, but this will not run also, right? Not failed, but not running, right? And this will say upstream failed. So this way, this will be stopped. Okay. Now why this is stopping, and is this a correct behavior or not? So yes, this is a correct behavior, because I was running the pipeline. First task got completed, second task got failed. Then what is the purpose to run the third task when second task got failed, right? But there can be a scenario when you are running a task, right? Multiple tasks. Maybe you ran 3 tasks, but you want to get it succeeded, like this task should run even if these 2 tasks are failing, right? So what's the scene here, right? In that case, if this is the situation, then this will also not run. And that is where trigger rule says, by default, okay, by default I set it as all success. Now what is this all success means? All success means all the upstream tasks should be succeeded before this task to run, right? So in this situation, for this task to run, there are 3 upstream tasks, and all tasks should be succeeded, not in failure state. Then only I will run this task, else I will not run. And this is what trigger rule says. But trigger rule says, okay, I will give you an option also, that maybe you want to run your pipeline even after a failure, right? If there is a failure, then it does not mean that I don't want to run. Maybe there was a possible scenario that this will fail. Maybe API was not available at that time, but remaining API was available, and I want to go ahead with the remaining API, right? So in that case, although by default value is all success, but we have multiple options about trigger rules, like all failed. So if all upstream failed, then we want to flow in some other direction. That is also possible. So this is another trigger rule which we can set into a task. So basically this is on a task level, right? And then there is a none failed. None failed says no task, no upstream task should fail. It can have another state like success, skip, scheduled, but it should not be having a failed status. So this is another one. Then we have all done. All done says, I don't care about what is the status of your task, but all should be done in any way, either success, fail, skipped, but it should be done, right? So these are the few trigger rules that we can set. And that is where skip says, a skip propagation one was that if your upstream task, right, let's say, see, I have these multiple tasks running this way, right? and somehow this task got skipped. Okay, not this one. This maybe this is a branch Python operator, right? And this flow ran, right? No, not this. Maybe this is a branch Python operator and this flow ran, right? But this got skipped, right? This got skipped. So whatever task will come after this will also be skipped. Okay, even after joining this, right? That was the end, that also got skipped. So even skip was happening from here, all the tasks will be skipped if trigger rule is set all success. So that is where we have a different trigger rules. And in our case, right, for our case, at least none failed as a trigger rule will save us. Okay, so where does this all trigger rules come is present? We can go to Airflow UI, Airflow documentation, and you can search for trigger rules and see here, these are all the options that we have available to set: all success, all failed, all done, one failed, one success, none failed, none skipped. So these are few options that we can set for our use case, right? As I said, this will be running on a task level. So I'll go to end task. This is the task, right? And this task should have another trigger rule, right? That it should have a none field. Otherwise, this will always be skipped. But end state, we want to either success or fail. So that is where I said none failed. If there is no failure, then run this end flow, and if this gets succeeded, means our pipeline is getting succeeded, right? I set this. Now I'll go to DAG. Of course, I have multiple runs now. I'll go to this. See, multiple jobs are running, but all end are skipped. See, everything is skipped. These are skipped because these were in the part of flow, branching flow. That is why this is skipped. But this one should not have been skipped. So what is the time? This is the last one, I would say. So this is the 4 o'clock, right? 4 o'clock my last pipeline ran, and after that I saved this file changes. So at 4:02, basically now I think there should be one another. If I refresh it, see, if I refresh it, there should be one more run. Yeah, see, this is the run at 4:02, and if you see here, end got success, but before that end was skipped. So this is how trigger rules runs in a action, right? So now you understand about trigger rules, how to use it, when to use it, and when not to use it, and what is the default value, right? So in today's video, whatever we were discussing, all of these things are done. But of course, this is not how we implement the real code in real environment. So if you do lecture number 11, you will have, like, after that, I don't think you will have any difficulty to writing any kind of DAGs, any complex situation kind of DAGs, because till then we will be almost good with writing a good DAG, understand each and every concept. After that, we will go into sensor, and then yeah, there will be another one most important video will be communicating with outside Airflow world, because that is not how we write the code. So maybe this code is running, right? But this is not how we write the code in real-time environment. That will also be discussed when we will be talking about connecting with outside system. Okay, outside system is which is not running into the Airflow machines, right? Outside of Airflow world will be considered as a outside outside system, I would say. Okay, so for today's video we are done, and we will meet in the next video. Till then, bye bye.